Okay, so this will be the first video for week 2, covering minerals and rocks. Uh, when we talk about the structure and origin of rocks, we know that rocks are all composed of what we call minerals. A mineral is going to be a natural, inorganic solid that has characteristic chemical composition and internal structure, and it also is going to have a characteristic set of physical properties. You can see down below that there's a couple pictures of minerals. However, there's going to be more than 4,000 different types of minerals that are found in the Earth's crust. You can see here the most abundant of all those minerals within the Earth's crust is going to be our plagioclase feldspar. However, you probably are more familiar with quartz and clays and micas. So when we talk about how those minerals join together and then form rock, we actually have different types of rock that can form from those minerals. The first type is going to be our igneous rock, and this forms when we have molten rock or liquefied rock that has turned into magma and it starts to cool. It's going to form this igneous rock. Nearly all of our igneous rock are going to be formed or made of crystals and various minerals, and thus you can see that in the actual rock structure itself. There's two different types of igneous rock. They can be extrusive and intrusive. Extrusive igneous rock means that the lava has actually cooled or reached the Earth's surface and then began to cool there. Intrusive igneous rock means that somewhere along the way, as that magma is moving up through the Earth's layers, it has reached a point, started to solidify, and cooled down beneath the Earth's surface. Here's a couple pictures of igneous rock. You can see within each one of these pictures, there's different colorations of the rock and thus different minerals that make up those rocks. Next type of rock is going to be sedimentary rock, which actually forms from older rocks. As those rocks begin to break down over time into smaller pieces, those pieces will actually join together, be compressed, and then cemented together to form what we call sedimentary rock. This process, forming sedimentary rocks, relies on what we call weathering, and we'll talk about that more in the next video. But weathering is going to be the natural process by which a rock decomposes, either by wind, rain, or temperature changes, and breaks down into smaller sediments. Sedimentary rock, we have a lot of that here in Kansas. Our sedimentary rock, you can see, is going to have different layers built up within it. And if you've ever been to the Grand Canyon, the whole canyon itself is going to be made up of sedimentary rock as well. So you can see those layers throughout the rock. And this is where we get our limestone and our sandstone from as well. Sediment rocks form in two different ways. They will have layers that compress over time from the weight that's above them, and those will force those little tiny pieces together closer and closer until eventually minerals will dissolve in that water, seep between the bits, and act almost like a glue, gluing those tiny pieces of sediment together. How we go about naming those sediments is based on their size of those fragments that make up the rock. The third type of rock is going to be metamorphic rock. This is going to be a rock that forms from other rocks as a result of intense heat, pressure, and chemical processes. What happens with metamorphic rock is that the heat and pressure within the Earth's crust is going to cause the rock above it to change, or as it subducts, to change the texture and the mineral content of that rock. This can happen all two different ways. By heat alone, so as the rock, if we go lower in the Earth's surface, there's going to be more heat, and that heat can change the rock, or it can be by both heat and pressure. And this is the most common form of forming metamorphic rock. And this happens when we have those subduction zones within our Earth's plate and deep down in the Earth's crust as those rocks begin to be pressurized and heated up from the Earth's interior layers, and it starts to melt and change that rock. Here's some pictures of metamorphic rock. It's almost like it's the two other types, igneous and sedimentary rock, kind of together. However, you usually see these guys are going to be smoother in their layers, smoother in their colorization, not as spotty as our sediment or igneous rock. So when we talk about the rock cycle, this is actually how we can go about forming these different types of rock and how they can actually reform into the other types as well. And so when we talk about the rock cycle, we have our sedimentary rock at the very top, which once again forms by weathering and erosion. When it starts to subduct and go below the Earth's crust, we have heat and pressure, which then can form it into metamorphic rock. And as that metamorphic rock continues to subduct and go below, it starts to melt into magma, which magma then can cool and form our igneous rock. So that's how the cycle can go. And you can see from here that igneous rock can then form into metamorphic rock, and our sedimentary rock can also be subducted, melted into magma, and then form from there our igneous rock. So how do scientists go about dating or telling how old rocks are? Scientists are able to tell how old a rock is using two different types of methods. They've developed these methods throughout time in order to, one, relate how old the rock is to the rocks that surround it, the layers maybe above and below, and then how old that rock is as it relates to the date of Earth as well. The first type of dating a rock is known as the principle of superposition, meaning that you can assume that there's going to be no disturbance in the position of the rock layers. So when that assumption can be made, that the rock that is the oldest will be on the bottom and the rock that is the youngest will be on top. Here's a picture of that. So if we were looking at this, these different layers within the Earth's crust, you would assume from this that there's no obvious changing of the rock layers. It's uniform throughout. But from this, we could say that A is going to be older than B, B is going to be older than C, and D being our youngest rock that we have in this area. The other type of dating rocks is known as radioactive dating, which can help determine a more exact age of that rock. So what we know about elements is they go through radioactive decay, and as those minerals within the rocks go through this decaying process, it happens at different rates. So physicists have determined that they can actually identify the rate at which these elements are currently decaying and then give us a more precise age of that rock. And this is known as absolute aging. By using this radioactive decay, we can then come upon what we would call the absolute age or the actual age of that rock. Okay, so that's our notes for the first section. Check back tomorrow for the next section.